All right. Hey, everyone. Welcome to the IBM Cloud Kubernetes SIG meeting today on Wednesday, August 1st. My name is Sadhu Zala, your meeting host today. Please keep in mind that this meeting is a public meeting. It's being recorded and we'll make it available on YouTube SIG channel, Kubernetes channel. Before we go ahead into the agenda, I see one new person on the in the meeting today. Brian. Is that it's on? I see Brian's iPhone. Just wondering if you wanna introduce yourself. That's really fine. But anyway, let's go ahead and start. We can even come back to that point later. So in the agenda today, we have a couple items there, and then we're gonna have some open discussion. So Jake Kitchener, thank you so much for for willing to provide the IKS demo and multi AZ cluster today. So all yours.
Okay, great, thank you. Let me go ahead and share my screen. Let's see. So hopefully, shrink that. All right, now I can see what's going. All right, so yeah, as mentioned, right, so we recently introduced the capability for IBM Cloud Kubernetes Service to have multi-zone clusters. And essentially, this is all about introducing increased availability for customer workloads on the Kubernetes clusters being provided by the service. So, for the first, we'll say, I guess, year that we've been in production, we have only supported having worker nodes in a single availability zone for IKS. So if you decided that you wanted to build a cluster, you would pick a single data center. So Dell 10 or Washington DC, data center 7, something to that effect. And we didn't have the ability to add worker nodes from additional zones. So basically, we've had a long time demand to basically provide a means for customers to have better availability, and so that's sort of the mantra behind introducing MZR. And it's interesting, like a little bit of background, right? So it's from a usability perspective, we've kind of had the ability to kind of like hack together multi-zone clusters internally for quite a while. And we've had some of our internal IBM teams using this capability on their own, but it was lacking a couple of key things. So one of them was basically the ability to manage pools of worker nodes, and I'll talk a little bit more about that, and then also the ability to have a load balancing solution that is highly available across zones. So those were the two key features that we've been working on to basically prepare this function for GA, and it's ready now. So, from a Kubernetes perspective, right, like for those that aren't familiar, Kubernetes does have this notion of failure domains, and there's a labeling system where you can specify regions and zones for particular worker nodes in kube clusters. And there's some built-in facilities within Kubernetes from a scheduling standpoint that allows you to sort of address those things. The default behavior in any cluster that has worker nodes with failure domain and zone labels is that it will try to do anti-collocation of the pods in a replica set across zones first and foremost. And then secondarily, it will also try to do anti-collocation of across worker nodes within those zones where available. The default behavior is not required on scheduling, it's preferred on scheduling. So, if I had a 3-zone cluster and I created, 6 replicas, if for some some reason the nodes in one of those zones are unavailable, to add the they will be cross volume claims and location. If you have a storage provider that has that zone awareness. And so that's one of the other features that's provided as part of our multi-zone support for IBM Cloud Kubernetes Service is a block and file storage provider for Kubernetes that is zone aware. So those were some of the additional features, required to really have a fully fleshed out implementation of multi-zone support. So that kind of covers a little bit of the Kubernetes capabilities. We can talk a little bit more about, I think worker pools is maybe for IKS the most, interesting addition. So previously in IKS, you basically just got a big list of all the worker nodes that were in a given cluster. And when you, added a worker node, you basically just got to pick, hey, what VLAN should this worker node be on and what flavor did you want to use? And you would choose those things every single time that you added nodes. So, once you start moving into multi-zone, you really start having a lot more variables in play, and we'll kind of show an example of this. So, let's see. Oops, I just wanted to make sure that I'm missing anything in the chat here. Okay. So let's say, I've got my existing multi-zone cluster here, and I need to scale it out. With the addition of worker pools, it's a very simple process. We've already stored information about the VLANs that you're using for that particular worker pool, the machine type, and all that the customer has to do is change the number of nodes that they want to have per zone. And you can see you get sort of like a live update of the costs that are going to be associated with that, et cetera. So I can just simply say resize worker pool, and now it'll scale out my cluster. So this is, probably the biggest change, again, from a cluster management standpoint that was introduced with multi-zone clusters. So you'll see I said, okay, well, now I want 3 per zone. And if I go look at my worker nodes, I'll see, hey, here's a whole bunch of additional worker nodes that are automatically being provisioned into my cluster. So that was really important to us, right? Without the ability to have the worker pool concept, right? Every time you wanted to scale out, you'd have to go pick VLANs for each zone and machine types for each zone, and it sort of was like a manual process, and the bookkeeping was left to the user to make decisions about, like, well, how do I keep my cluster balanced from a capacity standpoint? And that's just really important for the kube cluster, for the kube scheduler, right? It's going to, because it's going to do best effort load balancing across the zones. If you end up with a zone that has dramatically more or less capacity than the others, then you end up with some weird scheduling situations where, potentially, users aren't going to get the 3 replicas that they ask for if they're doing things like required during scheduling for anti-collocation. So, this is really important for us to basically have this capability as part of the product, is this management of worker pools. I can also add additional worker pools to my cluster. So if one of the things that a lot of our customers do is they use the edge node concept, right, where they have some worker nodes that have private only VLAN access, so that they're basically walled off from the internet. I can create another worker pool that is using private only VLANs. I may want to have another worker pool that I'm using for a different application or service in my cluster that needs a different type of hardware. So, maybe potentially you need bare metal nodes with GPUs, various different features and functions that they may need to have a variety of node types in their cluster. Yeah, the other thing that doesn't show up through the CLI is that we also allow you to apply labels by pool. So this is just an easy way to keep, pools of workers organized from an application side, is that you can apply labels. We do apply some labels by default to the worker nodes as well. That's also there by default so that it's easy to identify which nodes are a part of which pool. And then, oops, how do I, let's see. Let's scoot that down a little bit. So let's take a look or I guess any questions as far as, management of worker pools or some of the differences that customers will see from just, I guess, like the IKS side of things. All right, so I'll move on to kind of the kube view of the universe. So I can launch in my kube dashboard here. So, we'll go take a quick look at the nodes and we'll get some, we need to look at a specific node. So if I go look at this node and I look at the labels, right, you'll see we're automatically applying the failure domain labels to this. We also have like machine type, VLAN, right. Oh, and then also region. So you can say US East is the region. So those are the important labels that are needed in order to basically have the Kubernetes schedule properly do load balancing across the available zones of any given cluster. All right. So I think that the other item of interest from a multi-zone standpoint is the multi-zone load balancer. So in our docs, we do have some nice information about the multi-zone load balancer and how we're using that with multi-zone. Here we go. So basically, right, in IBM Cloud Kubernetes service, we do provide basically ingress support via our ALB or application load balancer, right? It's a layer 7 load balancing mechanism. And in a multi-zone cluster, what we'll do is we deploy an ALB instance in each zone for availability purposes, obviously. And IKS does use an in-cluster ingress, right? The ALB is actually running in cluster. It's not external to the cluster. And what we're doing is to balance the zones. Essentially, what we're doing is we're setting up zone load balancing. Essentially, it's GSLB with health checking and DNS. So we're automatically registering a domain name, SSL certificate, if you want to use SSL or you're going to use our domain. And then we're health checking the ALB in each zone for that domain so that, if for some reason one of those zones fails, the health checks will fail and the DNS name resolution will drop that zone out of the resolution so that you kind of retain availability across the 2 remaining zones without having any workload being, routed off to a dead end. So that was, I think sort of the one of the critical pieces of the multi-zone support is really having that built-in capability for multi-zone availability for networking. And so how that shows up on the, go ahead.
Jack, sorry, quick question on that architecture, the diagram right there. I was just wondering with the multi-zone, is single master is good enough or a multiple master is recommended, or?
Yeah, that's a great question. So today we do single master for the 3 zones. If you are looking for even higher availability, right, you can provision 3 separate clusters, 1 per zone. But we are working on multi-master support so that it would be a 3-master instance for each cluster spread across those same zones. So I don't have an exact date for that. It's, I would say in the next 30 to 60. Okay. From the app domain.cloud, right, you'll see it comes back with name resolution for all 3 of those instances. So, if for some reason the ALB or an entire zone had a failure, right, then our GSLB is going to help check that particular endpoint out of the response, and you would no longer have traffic headed that way. The TTL on those is 30 seconds, so that's kind of like the fastest that, in a failure scenario, right, within 30 seconds, essentially, we would stop, resolving that particular endpoint. So, right, and then, not very exciting, but great, here's my domain. It's, as I refresh, it's load balancing between the various endpoints on the back end. Something that I guess does come up from time to time, which is there any ability to have affinity so that if traffic comes in through ALB in zone 3, that there's a preference to keep the traffic within that zone if there's pods available to service the request there? And today it doesn't. Like, basically the ALB and services in Kubernetes don't do any kind of weighting on the load balancing of the kube proxy on the back end for a particular service. So it does not have preference to try to keep that traffic local. It will just divide, it'll spread the work across the pods on the back end regardless of what zone it's in. I do know that there's some work being done upstream for kube proxy to try to introduce some basically zone affinity in the load balancing weights for those things. So that's something that may come in the future. Yeah, I think that's basically it. We kind of covered worker pools, right? It was sort of the kind of the operations facing process for managing worker nodes in multiple zones. We touched briefly on the ability to include zone location on the storage providers, and then obviously the MZLB being the final piece of the puzzle, so that we can have highly available application routing externally to the cluster as well. That, I think, pretty much does it. Any other questions or comments that I can answer? All right.
Well, that was great, Jake. Thank you so much, and thanks for answering my question as well. I lost the connection in between. Somehow it's unstable at maybe connection point at work, something.
Gotcha.
Yeah.
So you heard my response to the multi-master question?
Yes, I did. Yeah, I think almost at the end I lost the connection. So
Gotcha.
I'm good. Yeah, no, thanks. And it was good to know actually the zone affinity thing you mentioned. Something I think it seems like a work in progress upstream, right? And that'll be. I mean, I heard about node affinity, pod affinity, zone affinity was something new. So.
Yeah, specifically for services, the zone affinity I think is interesting that that work is coming. So.
Yep. Cool.
All right.
Yeah. Well, thank you so much again. If there's no other question, I guess we can keep moving now. The one thing, Jake, next one is me in the agenda, but in open discussion, I don't know who put it there, but there's a mention of you about KubeMark.
Oh yeah, I'll talk briefly about that on this call when we get to open discussion. Yep.
Okay. Yeah, perfect. So do you want to go ahead, or you want to take the thing one I wanted to mention, or?
Sorry, say that again?
No, I thought if I hear correctly, you said you will just brief on that, or?
Yeah, I can talk about it now if you'd like. So,
Yeah, then I'll take my turn.
yeah, sure. So KubeMark, for those that aren't familiar, was some work that was done upstream as part of the Kubernetes core project. It's part of core to basically do scalability testing of Kubernetes masters themselves. And essentially, like the implementation that exists out there today was built to support GCE, not GKE. So today, well, I guess now it supports GCE and IKS. But the idea is that it would spin up two clusters, right? One cluster would be, I guess, what we've been calling the spawn cluster, and one that's called the KubeMark cluster. And the idea is this, is that the spawn cluster is basically just a kube cluster that's used to host what's called hollow node pods. And essentially what these things are is like each pod contains all of, or most of the components of a worker node. And it's actually leveraging like the kubelet and kubedns, kubeproxy libraries, but basically just stubbing out some of the back end so that, you know, when that kubelet phones home to a master and says like, hey, give me the work that I have, instead of actually spawning pods, it just sort of responds back to the master and says like, yep, I totally did that, even though it doesn't actually create the pods. So, you know, the interesting thing with this is that essentially it's much cheaper and faster to do extremely large scale tests of Kubernetes masters. And so the idea is like the spawn cluster may run, oh, you know, let's say 100 or 1,000 of these hollow node pods. And each one of those hollow node pods is configured to register as a worker node in a KubeMark master. And essentially the KubeMark master now thinks that it has 100 or 1,000 worker nodes, whereas in reality, right, it doesn't have any actual nodes. It's just scheduling away merrily, but no work actually gets done. So, you know, for us, previously, you know, we would do a scale test of, say, 1,000 worker nodes. It would cost us in the neighborhood of $1,600 to $2,000 to go do like a 24-hour run of that, which is about how long it would take to basically get all those things spawned, get them registered, get workload on them, et cetera, and run through the end-to-end test. Whereas, you know, now with the KubeMark support for IKS, you know, we can spin up the KubeMark and the spawn cluster in a matter of a few hours, simulate those 1,000 nodes, and it really only costs us about $20 to do the test run. So it's much faster and cheaper.
How do you know the simulation is accurate? How do you know that you're getting a high level of confidence that the way you're simulating it is also going to accurately model the real thing? I love that you're saving your money. I'm just curious how you know it accurately models it. Yeah,
and we know that is not a perfect model. So, for example, one of the things that we're going to try to do as a follow-on is work with the Calico. So, like, we use Calico as, you know, our layer 3 routing for the pod networking, as well as obviously for kube network policy. And so, Calico, you know, the policy controller and the Calico node agent that runs on all the worker nodes does put load on etcd and on the kube API server. So, you know we're not getting an apples to apples comparison. It's like close, but it's not exact. As far as the accuracy of the data that we get back, basically based on the kubeproxy and kubelet data. So, I mean, it's running a full-blown kubelet runtime and a full-blown kubeproxy runtime. They're just stubbing out the back end so that, you know, when kubeproxy calls the kube API server to get a list of all the services, like the kube API server is getting the same request that it would get from a real kubeproxy. It's just that when the hollow node kubeproxy gets that data back from the API server, it's not going to go manipulate, you know, thousands or tens of thousands of IP tables or IPVS rules, right? So it's just like the only thing that gets faked is like the data plane manipulation that those agents would do on the worker nodes. So the same thing goes for the kubelet, right? Ordinarily a kubelet would have a watch for work that it needs to do based on scheduling decisions. So it has that same watch in place. It's doing the same polling for config map data. It's doing the same polling for secret data, et cetera, that a real kubelet would do because it is a real kubelet. It's just that where the rubber meets the road, right? Like there is no CRI being plugged into it to actually go spawn containers in a container runtime on the back end. So it doesn't provide anything as far as scale testing of worker nodes. It's all about placing load on the Kube API servers and etcd, essentially, for scale testing.
Great answer. Great answer. That's really cool. It makes a lot of sense.
Yeah, there's, one of the things, so it's the motivation for us is that we wanted to have a cheaper, faster way to do scale testing of the IKS masters. And we had looked at KubeMark and Hollow Node way back, very early days when we started work on IKS. And the KubeMark portion of the project really wasn't in a decent enough shape to go put the effort into it. And we really wanted to start beefing up the amount of scalability testing that we're doing on a more regular basis so that it's part of our regression. And so we decided to kind of go take a second look at it. And unfortunately, the KubeMark documentation is lacking at best. I know eBay does have a fork of the Kube repo that does have a little bit more information about how to go run KubeMark runs, but even that is out of date and non-functional at this point. So, we'd like to, help in the community to obviously ensure that we've got good docs on how to go do IKS runs, but we'd also like to see if we can get things cleaned up a little bit so that at least the GCE support is, well documented and still properly functioning. So that, and hopefully, SIG scalability and some of the other cloud providers will maybe be encouraged to also take a closer look at KubeMark again, and we can maybe steer a little bit more, what's the future of that tool, and maybe even part of conformance testing, who knows where it may end up after that. So I think that pretty much covers it for the KubeMark side of things.
Yep, absolutely. Is there any more question? If not, Jake, thanks again so much. Yeah, that that was great. The next one in agenda, that's something very quick. Charter. So in last week or so, couple weeks, basically, it seems like the steering committee is encouraging all the SIGs to have their own charter. So it's like a charter file. And they already started the efforts. They have received few. They have actually created a template. So I have provided a link here for the template for the charter. They also been assigning a specific reviewer from steering committee and from the community, like 2 reviewers for each charter. So that's something I already started working. Actually, yesterday I was looking at the template and creating the one for ourselves. I will be sharing it with, I'll be working on it with, Khalid and Richard and Doug and others from, leadership perspective. And then we'll be sharing with everyone, with all the SIG members before we create a PR. So that's something, I just wanted to give heads up, look forward for it. We should have our own charter and we'll have it, we'll make it available soon. Other than that, I don't see any other topic for today. If there is any other discussion, any questions, I guess we can continue. But we really had a good call with Jake's presentation today.
So I did have a question about the charter. Do we want to? Is the plan that we'll have some discussion in here on sort of trying to formulate like what the charter content is going to be? I know that we've had some sort of side discussions via emails, but you know, what's the process that we want to use for putting together that charter before submission?
Yep, no, that's a good question, Jake. And the way I was thinking was, like I said, I just wanted to create something like a draft and share with other SIG leads. So right now, you know, Khalid, Richard, and myself, we are the 3 co-leads. So I want, yeah, 3 of us to take a look at it, and then, you know, I will basically share it with everyone through the group we have, the Google group for IBM Cloud. And I'm hoping that in next meeting we can actually just have it in the meeting, and you know, any comments from anybody we can sort of try to incorporate and, you know, have it final, and then basically create a PR. Or even, you know, with the email, if it works out earlier, then we may not need to wait for 2 weeks before we create a PR. But I want to share with every SIG members, you know, have their input if anything sort of, you know, we want to add, modify, right? So that's the plan. Yeah.
Okay, cool.
Sure. Thanks. Anything else, anyone? If not,
question for network policy. I think, is Richard on the call?
Yes, he's actually taking minutes as well.
Yeah, taking notes here. I'm here.
Great. I had a question on how useful Kubernetes network policies have been for you guys, and if you see a lot of uses for them. The reason that I ask is we're looking at promoting GA egress and IP block for Kubernetes. It's stayed in beta since 1.8 because we lacked a lot of production feedback. I'm not sure if you have any that would be useful to add to the GitHub issue.
I mean, yeah, certainly said you could send me the issue. It's definitely been a benefit to have Kubernetes network policies. I mean, we use Calico and effectively implemented via the Kubernetes network policies. And so we've got a lot of host protection and then some policies within the cluster. And I know customers have been using them as well to protect, you know, a certain namespace. And I think at some point egress came along and then, you know, folks are waiting for that. So that's been in use as well.
I think
so I think it's great to go to GA. I mean, we're using it like it's GA.
Yeah, I think that's same kind of model for the IBM Cloud private side. Customers or clients are using those network policies to isolate workloads either within a namespace and or across namespaces, and we document that as a kind of a GA feature.
Okay, great.
So, Chris, if you wouldn't mind sharing that in the doc here or the notes, and I'd feel free to update that or make any comments that you feel might help the discussion on that GA.
Sure. Yeah, I will place that in here in just a sec. It's just been production. There's not much to add to make it GA. It was really just maybe lacking implementations and whatnot that we've delayed it so long.
Hey, Richard, are we using IP block in any of the network policy that we ship by default?
I'd have to go back and check, but I don't think so. I think most of it's mostly label based network or namespace and pod labels.
Gotcha.
Yeah, that was kind of one comment on the proposal, that when I added IP block, it was also added for ingress as a possible option. But others haven't really seen a benefit to IP block on the ingress side as much as egress.
That's great, and I think we can continue discussing this offline as well, right? Unless we want to continue any more discussion there, anyone? So Krish, you'll be putting the link in the notes, right? You said. Actually, I was trying to write some notes there. Okay, there you go. All right. So we'll be sharing. You already shared it. So thanks. Anything else for today? Well, seems like not. What a great call. Thanks again, Jake. Thanks again, everyone. Richard for taking notes. I know Doug usually takes it, but he's remote today, so he wasn't able to take it. I also tried to chime in and put few sentences there. So for the not the next week, but next meeting, the following meeting, Khalid and I, we work with the Animesh, and we're gonna have a Fiddle presentation from the Kubernetes perspective. But we'll be updating that in the agenda. And that's it. Thank you so much, everyone. We'll talk to you in a couple of weeks on this call, and meanwhile, we'll discuss offline via emails, Slack channel we have for IBM Cloud and whatnot. So thanks again, and have a nice rest of the week, day. Talk to you
Thank
later.
you.
Yep. Bye.
Thanks. Bye.
Bye.